What is SSS and when do you use it? An SSS represents side, side, side. That's what the S's mean. Side, side, side. And when do we use it? Just a reminder, this is for task 6.9, so this should be the title at the top of your paper. Okay, just a reminder of what your notes should look like when you're taking notes from a video, and this is going to be video title number 1 for this section. Before we begin to explain what side, side, side is, let's talk about congruent triangles. And in lesson 4-1, which was for the previous task, we learned that if two triangles have 3 pairs of congruent corresponding angles and 3 pairs of congruent corresponding sides, then the triangles are congruent. So what we're saying is if we have angle A is congruent to angle X, B is congruent to angle Y, and angle C is congruent to angle Z, and if we have AB congruent to XY, YZ is congruent to BC, and AC is congruent to XZ, then we will know that the two triangles are going to be congruent to each other because all the sides and all the angles are congruent. However, you do not need to know that all 6 corresponding parts are congruent in order to conclude that the two triangles are congruent. So instead, we can look at different parts of the triangles and figure out if they're congruent triangles. So we're going to look at 4 different ways to look at a triangle by comparing all their sides to each other's, or seeing if there's a couple sides congruent to the other, to a couple of angles. We're going to, well, I kind of worded that weirdly. However, we're going to look at different parts that we can look at of components of 2 parts of triangles to see if they're congruent by looking at certain parts of it instead of looking at all 6 corresponding parts. So the first congruence statement that we're going to look for triangle congruence is side, side, side. So you want to go ahead and write that down, that this is side, side, side. That means that we're gonna use the fact that these 2 triangles, this one here and this one here, are congruent to each other because all 3 sides are congruent. And so let's go ahead and write out what we have. We can see that CA is congruent to ZX, so we would write CA is congruent to ZX, excuse me. Side CB is congruent to ZY. And how do I know that they're congruent? Well, I can tell by the notation on the side. It's congruent to ZY. And we can also see that AB is congruent to XY. So AB is congruent to XY. Since all 3 sides are congruent to each other, we can then say that these 2 triangles are congruent. So triangle ABC is congruent to triangle XYZ by side, side, side. And here's a more formal definition for you. Side by side, 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 or SSS postulate. If 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. And once again, here we have this triangle GHF is congruent to triangle PQR. And here's a vocabulary tip for you. The reflexive property of congruence tells you that a figure such as BD in the next example is congruent to itself. So I'll show you what I mean by looking at a triangle. They're actually talking about when a triangle is connected. So we can say when 2 triangles are connected. Here is an example where we would use SSS and also to compare 2 triangles, but also I want to take this opportunity to discuss what a flow proof is. And I really like flow proofs when we're talking about triangle congruence by the side, 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 or side, angle, side. So let's first take a look at the example, then we'll talk about how we proved it. We have a bridge design, and the bridge grinders are the same size as marked. So we're going to write a flow proof for this. So notice that we have this triangle here, which is A, B, C, and D. Well, sorry, it's not one triangle. It's actually two triangles together. And we just want to prove that these two triangles are congruent to each other. So we are first given some information. We're given that AB is congruent to CB. And notice that they put little congruence marks there. And then we're also given that AD is congruent to CD. And so these are also some congruence marks on there. And what we want to prove is that this triangle here, I'll put a check mark, and this triangle here are congruent to each other. So to do that, we're going to go ahead and write in what's given to us, and then also we're going to do some deductive reasoning to figure out if they are congruent. So we're going to go ahead and write that AB is congruent to CB, and that's given. Then we're also going to write AD is congruent to CD, and that's also given. And we also know that if two triangles share the same side, then that is also going to be congruent to each other. So I'll put 3 marks there to show that BD is congruent to BD. This can be confusing to students, but it's only confusing because you are not imagining the two triangles separated. Imagine that these two triangles here, this triangle and this one, are separated. If they were separated, you would then realize that BD would be congruent since they shared a side to begin with. And so now that we have a side is given, we can then say that the two triangles are congruent by side. We're going to really focus on flow proofs and then convert them to paragraph proofs or to bar proof, mostly paragraph proofs, after we have mastered the flow proof for the congruent statements. So I want to remind you the outline for a flow proof. We would have usually about 3 boxes since we're talking about like side, or side, angle, side, or any one of the congruent statements. And so we're going to go ahead and put information in here for us. I don't want to put that because that would confuse you. We're going to go ahead and put some information in here, in here, and in here. And we can use deductive reasoning or what's given to us. And then, depending on how much information is given to us and how much we need to prove, you can then have this all go to one spot. And in some cases, the box would continue on. It depends on how much information you need to include to prove your statement. But at the very end, I do want you, excuse me, let me erase that. At the very end, I do want you to write down whatever congruent statement that you would use. So we'll put here, the congruent statement would go there. Congruent statement. And we're focusing on 4 of them. Forgot some arrows on here. I like to put arrows so we know which direction we're going in. Okay.